In this session, we are going to consider the connection between a Cauchy problem and a Volterra's integral equation. The Cauchy problem is a differential equation with initial conditions. So we are going to take how to convert a Cauchy problem to a Volterra's integral equation. First, let's note this. Note Let's do this. If you are having several integral like this, you can convert it to a single integral by doing equating it to equal to 1 over what? N minus what? 1. That is the number of integrals and the number of what? Terms. N minus 1 factorial, integral from 0 to s, s minus t, raised to the power n minus 1, f of t dt. So you should know this. We're going to use this in what? Converting a Cauchy problem to a Volterra's integral equation. So let's continue by considering a first order ODE with initial conditions to a Volterra's integral equation. Let's consider the equation. With the initial condition, u0 equal to u of 0 equal to u0. Now this can be written as let's multiply each of the term by ds. So the resulting equation becomes now let's integrate both sides of the equation. Since the initial condition, the initial point starts from 0, we're going to integrate from 0. Since it's a Volterra's integral equation, I'm going to integrate from 0 to s. For better communication, let's change here to t. Let's see here to t, since you are integrating from 0 to s. If you integrate this side, you're going to get what? U of t evaluated at 0 to s, which will be equal to integral from 0 to s dt. So if you insert the upper limit, which is s, you're going to have u of s minus the lower limit, u of 0, to be equal to this side. Integral from 0 to s, f of t, u of t dt. You have u of 0 to be equal to u0. Now you substitute the u of 0 to their side. I'm going to have u of s minus u of t equal to integral from 0 to s f of t u of t dt. Now let's head it to the other side. Now our u of s to be equal to u naught plus integral of 0 to s f of t u of t dt. So we are able to convert this ODE with the initial condition, that's the Cauchy problem, to an equation involving an integral sign. And this is our unknown function, and this same unknown function appears another integral sign. So this is what? An integral equation, and we are integrating from 0 to x. This makes here to be a Volterra's integral equation, and u naught is our free term. We look at how to convert a second order ODE with its initial conditions to a Volterra's integral equation. So second order, let's consider the second order differential equation. With the initial conditions, u of a to be equal to alpha and u prime of a to be equal to beta. So from this side, you could easily see that the highest degree is 2. That's a d square u ds square. Over here they give you an equation. Check the highest degree and select that and take that highest degree. So let's take the square u ds square, and let it to be equal to another unknown function. Let's say y of s. So we can rewrite this part as del the s into bracket u prime of what? S, which is equal to what? U of s. It's like if you add the derivative on it, you're going to get u prime of what? S. You can rewrite this as that. And so let's multiply each of the term by what? ds. Now let's integrate both sides of the equation, and the initial point starts from what? A. So we're going to integrate from a to s, since we are converting this to a what? A Volterra's integral equation. A to s. Now for better communication, let's convert here to t. Which will be equal to integral from a to s y of t dt. If you integrate this side, you're going to get u of what? You're going to get u prime of t. U prime of t equated at a to what? X, which is equal to integral from a to s y of t dt. Now let's insert the upper limit. I'm going to get u prime of s minus u prime of what? A, which will be equal to integral from what? A to s y of t dt. Now we know our u prime of a to be beta. We're having our u a to be equal to alpha and u prime of a to be equal to beta. And so let's substitute this u prime of a into what? This. I'm going to have u prime of x minus beta to be equal to integral from a to s y of t dt. Let's make u prime of s the standard equation. I'm going to have u prime of s to be equal to beta plus integral from a to s y of t dt. So we now have our u prime of s. We have for d squared ds squared. So we are going to substitute, if we are done with the u of s, then we will substitute everything into it and work on it. So let's name here to be our, let's name here as our equation 1. And this will be our equation 2. Now, our first equation to be u square u s square to be equal to y of s. And the second equation to be u prime of s to be equal to beta plus a to s y of t dt as our equation 2. Let's write our equations first. From this equation 2, we need to what? Integrate both sides here. I'm going to have du ds to be equal to beta plus integral a to s y of t dt. Now let's multiply both sides by what? ds. I'm going to have our du of s to be equal to beta plus integral a to what? S y of t dt ds. Now let's integrate both sides. From the initial condition from a to what? S. A to s. So the variables here need to change to what? T. So I'm going to have integral from a to s du of what? T to be equal to integral from what? A to s. And integral sign is a linear operator. So integral from a to s beta dt plus integral from what? A to s, another integral from what? A to s y of t dt dt. This integral and this integral, so we're going to have something like this. Double integral here. Now if we integrate this side, we're going to get u of what? T evaluated at a to what? X, which will be equal to, if we integrate this, I'm going to get bt beta t evaluated at as plus, you're having integral from s, a to s, and a to s is double, which is what? N is equal to what? 2 from the previous thing to the n is equal to 2. So we're going to write it as 1 over what? 2 minus 1 factorial. Integral from a to s, then s minus t, 2 minus 1, y of t dt. This side, we are going to have u of s minus u of a to be equal to, here becomes beta into bracket what? S minus what? A. Plus, here 2 minus 1 is the same as 1 factorial. 1 factorial is the same as 1. So 1 over 1 is the same as 1. So plus integral of what? A to s, then s minus what? T. 2 minus 1 is 1. So y of t dt. And u of a was given in the equation to be what? Alpha. So u of s minus what? Alpha to be equal to beta s minus a plus integral from a to s minus t y of t dt. And let's send this alpha to the other side. I'm going to have our next equation to be u of s to be equal to alpha plus beta s minus a integral of a to s minus t y of t dt as our equation 3. Last, so this is our equation 3. Now we have to substitute this equation 1, 2, and 3 into this differential equation. Now we are having our u, d square du dx square is equal to y of s. So here is y of s. Y of s plus p of s. Du dx is equal to beta plus integral from a to s y of t dt. So into bracket beta plus integral from a to what? S y of t dt. Now plus the k of s, all into bracket u of s, which is the equation 3, which is giving us alpha plus beta into bracket s minus a plus integral of a to s minus t y of t dt. Y of t dt to be equal to f of s. Now let's open here. I'm going to open the terms that I will group the terms. I'm going to have y of s to be equal to this and this plus beta of what? P of s plus P of s integral of what? A to s y of t dt. This time this, so plus k of s plus alpha k of s plus beta k of s, this time this, s minus a, plus k of s and this, k of s integral from what, a to s minus t, y of t dt, to be equal to my f of s. Now let's make our y of s the solution of the equation, or better still, you can still group the items, this and this, this and this. So let's make it the solution of the equation. Y of s to be equal to this f of s minus beta p of s minus alpha q of s. Now let's end this one to the other side too. And minus beta q of s minus e. Now let's send the integral sign to the other side. We get minus p of s integral from a to s y of t dt. And this side to send it to the other side, making minus k of s integral from a to s minus t y of t dt. So we bring all this thing together as one, and all this thing also together as one. So it's like you can rewrite the whole of this relation as y of s to be equal to f of s minus beta k of s minus alpha beta p of s minus beta p of s minus alpha q of s minus beta q of s like s minus a. So this can be written as, can we write this as, so integral, you have integral sign here, y of t. So can we write it as plus integral of a to s. And have our ps here, which is minus p of s, and another minus q of s to bracket s minus t. Then all into bracket times what? Y of what? T dt. You should let capital F to be equal to the whole of this side. F of s minus beta p of s minus alpha q of s minus beta q of s to bracket s minus a. And to let this side to be our kernel. What is the same as can easily bring the minus out. So you can rewrite it as minus p of s plus k of s minus t all into bracket. So this is our kernel. So this whole equation can be rewritten as rewrite as y of s to be equal to capital F of s plus integral from a to what s k s t y of t with t. So we really see that this is an integral equation. So we are able to convert a second order ODE together with its initial condition to an integral equation, which is of this form. So the whole of this is our free term, and this is a kernel, and this is our unknown function. This is also our unknown function. The unknown function appears under an integral sign, and we are integrating from a to s, which makes it a Volterra's integral equation. So this is the end of this session.